Hey everyone, Mr. Skelton here. We are back at it, lessons 4 and 5 today. We're going to knock both of these out in one video, or try to. I'll go as quick as I can. And today the main focus is going to be on graphing inverse variation functions. Now you do have a little bit of experience with this. I talked about it in lesson 2. And so some of this will look familiar to you. So because of time, I want to jump right into it. So we'll take a look at this first example. I think we've actually done this one before, but I'm just going to review it real quick. There is a longer way to do this and a shorter way to do this. You can always make yourself a t-chart and plug some numbers in for x. So for example, we would plug in something like 9. If we plugged in a 9, 9 over 9 would be 1. If we plug in a 3, we would get 3. If we plugged in a 1, we would get 9. And we could graph those very quickly, right? 1 and 9 would be here. 3 and 3 would be here, and 9 and 1 would be here, and we would get something that looks like this. Now notice again that this graph approaches 0 but would never touch 0. Again, think of if you made this $9 and you divided 9 by any number. If the biggest number you could think of, 1,000,000, you would still have something there. So it's going to approach 0 but never get. That's why we have asymptotes. Also, if you made a t-chart, excuse me, you would have to take into account the negative x values, which would make the resulting y values also negative. And so you'd have -1, -9 here, -3 here, and -9, -1 here. And that's why we get this, what's called the hyperbola, when we graph inverse variation functions. Now our asymptotes are important, those dotted lines. That's your horizontal asymptote running through y equals 0. And your vertical asymptote, which is running through at x equals 0. In this graph, I didn't specifically ask for domain and range, but domain and range would be as follows. It's always good to know. It'd be all real numbers where x cannot equal 0, and then the range would be all real numbers where y cannot be 0. Now, if you recall back in lesson 2, I did give you kind of a shortcut so that you don't have to make a t-chart every time. If you recognize real quick here that if you take just the square root of your k value, you will get the 0.33, and that should make sense because if you plug in a 3 for x, 3 times 3, if you were to make this a proportion, 3 times 3 is 9. So really all I need, because we're just doing general sketches, is just that one point, and you can kind of work your graph along the asymptotes. And so just for the sake of time, that may make your life easier. So if you take the square root of 9, you'd get 3, so that means this 0.33 and this 0.33 would be the only points I would need, and you can bend your curve appropriately. Okay? If your k value were to be negative, you would still take the square root of that positive value, but just understand that again, if it's negative, it's going to go here and here. Okay, let's turn the page and keep rolling here. So here's an example 2 where we do have a negative k value. So I'm going to go the shortcut way here. I look at this, I see that I have a vertical asymptote here of x equals 0. I don't not have any shifts going on yet. I take 16, I take the square root of 16, and I get 4. But I do recognize that my k value is negative. So that means that this graph is going to take place in quadrant 2 and in quadrant 4. So I would go 4 to the left and up 4 here, and to the right 4 and down 4. And again, if you needed to make a t-chart for that to see that, you can do that, right? You could pick positive 4. What would you get when you put positive 4? You get negative 16 over positive 4, which would be negative 4, so that's that point. If you pick the negative 4 for x, you get negative 16 over negative 4, which would be positive 4, which is that point there. And so we would run our graphs along those asymptotes as best we can. Again, asymptotes are there so that the graph cannot cross them. So again, domain would be all reals, except x cannot equal 0, and your range would be all reals where y cannot be 0. All right? So I got a couple other graphs or situations where you look at it on number 3 and you say, wait a minute, that doesn't look like an inverse function. Well, obviously, if we can solve for y, we want to do that. So we get y equals 6 over x. Now, again, if you get a problem like this where 6 is not a perfect square, you can still take the square root of 6 and get roughly 2.4. So, you know, if you take the square root of 6, it's roughly 2.4, 2.44, 2.5 if you're graphing it. There are no shifts, so again, you have your asymptotes. I know I'm working fast through this, but this is kind of review for us. 2.4, so that means I'm going to go, because my k value here is positive, I'm going to be in the first and I'm going to be in the third quadrant. Basically 2.5, 2.5 and up 2.5, so somewhere in there, and then negative 2.5 and negative 2.5 somewhere in here, and my graph would look something like this. Okay. Domain, all reals where x cannot be 0, and my range would be all reals where y cannot be 0. Moving on. We're moving fast. Again, another situation where you look at it and go, wait a minute, that doesn't look right. So we'd go 2xy. You want to solve for y always. Divide by 2. So you get xy equals negative 2. Divide by x. And so you get y equals negative 2 over x, which is good to know. So when I look at this result, I see a negative k value, which means I'm going to be up in quadrant 2 and down in quadrant 4 because my k value is negative. I would take the square root of 2. Second square root of 2 should be 1.4. So 1.4-ish roughly 1.4. No shifts. Still have x equals 0 and y equals 0 as my asymptotes. And I'm up 1.4, up and over 1.4, 1.4, 1.4 somewhere in there. Left 1.4, down 1.4 somewhere in there. And I'm running my graph looking like this. And this is all I'm going to ask of you on your homework, quiz, and test. Obviously listing domain and range like we have been doing the past couple graphs. Number 5, graphing general inverses. I've given you a couple of these just so that you can understand really what this needs to be. This is what was given to us. We want to change it into this. If you recall from, I believe it's lesson 2, this just means that your k value is 3/5, right? If you think about how we got to that because you have 3/5 basically times 1 over x. And if you multiply straight across, that's the rules with multiplication, you get 3 times 1, which is 3, over 5 times x, which is 5x. So that's how you get this. But your k value is really 3/5. You can see that there. All right? So I just wanted to remind you of that before we keep moving. Next page. So now we're going to get into shifts. Now this is nothing new for you, and to start this out, I'm going to kind of, we call these shifts, we call these translations. Technically it's movements up, down, left, and right. Those are our movements, okay? And so with inverse variations with shifts, we usually write out the general form, right? K minus h. Now we already have a k value, right? We usually say h and k, but since k is our constant of variation, we can do plus or minus, like because it's going to be a vertical shift up and down, I'll put a v there. So that's basically the form where h is going to move us right and left, and where v is going to move us up or down. And if you remember, your h value is always kind of the opposite of what it is here. So if it's x minus 3, that means you're moving it to the right 3 units. Okay? So let's just jump right in. This really should be a plus or minus h because it can be either one. Let's jump right into it here. So here we have a situation. Now, you look at this, you're going to say probably, well, Mr. Skelton, this really isn't an inverse function because it has the plus 2. Ah, you're right. But we're taking that concept or idea of the graph of an inverse function and we're shifting it now. Now with this one here with the plus 2 outside, not attached to the x, that means this is going to move up 2. So the first thing that I do when I'm graphing these is, what is the parent function? Right? What is the parent inverse function? That would be y equals 4 over x. The reason I do that in my mind is because I know that if I take the square root of 4, I'm going to get 2. And 2 is that one point that I need to move to the right 2 and up 2, left 2, down 2. I'm going to be in this quadrant here because my k value is positive. All right? But I got to shift. So now everything of the parent function is going to shift up 2 units. That affects your asymptotes. The second thing I do is I write down my asymptote and the changes to that asymptote. Now the only change that's taking place is vertically, up 2. So my new horizontal asymptote is right here at y equals 2. I don't have any shifts with my vertical asymptote. I didn't shift right or left here, so my vertical asymptote stays the same of x equals 0. And now what happens is this point right here is like my new origin. So normally when you would graph this parent function of y equals 4 over x, I would have my dotted line here, my dotted line here, my origin is 0, 0, and I would go to the right 2, into the up 2, point, left 2, down 2, point, and there would be my graph, right? And everything is hunky-dory. So now all that's changing is that point of 2 is now shifted up 2. So you can do, when you would go to the right 2 and up 2, now that would be your original starting point on the original parent function, but now that's going to go up 2, 1, 2, and there we go. And then this one, again, if you were starting from the origin, would be left 2, down 2, and so now that's just going to move up 2, 1, 2. That's one way to think about it. The other way you can think about it is this point where my pen is your new origin. So go to the right 2, 1, 2, and up 2, 1, 2. You can do it that way. Left 2, down 2. Graph would look like this. Again, all you need is that one point. No, my graph's not perfect. Okay? Now, domain and range. Let's think about that for a second. So step 3 would be to plot your point with adjustment. Step 4, if I ask you for domain and range, I can't even remember if I do or not, but since it's honors class, it's always good to know. So domain would be all real numbers where x cannot be what? X cannot be. Do we have any shifts left and right? Nope, so it can't be 0. Range would be all real numbers. What can't y be? Y can't be, we had a shift, can't be positive 2. Right? It's not going to touch anything on the positive 2 line. So that would be your domain and range. All right, go ahead and try number 7 on your own. I know we haven't done one like this, but based on what I talked about right here in the shifts, right and left, up and down, you might be able to handle number 7, so give it a try. Check back with me. All right, so what's happening with our parent function, right? If I follow my own rules, my own steps, my parent function would be 1 over x. So think about 1 over x, take the square root of 1. Square root of 1 is 1. My k value is positive, so I know I'm going to be here and here. Those are the kind of things you should be, those thoughts should be being generated in your brain as you look at this problem. Now, before, I would go up 1 and left up basically to the right 1 and up 1, to the left 1 and down 1 for those points, but where is that going to all shift? It's going to shift to the right 3 units. So the second thing I do, if you remember, is my asymptotes. So now I have a shift to the right. I've been using blue pen. 1, 1, 2, 3. So now I have my vertical asymptote has been shifted. Do I have any movements up or down? No, I don't. So my y stays, my horizontal stays as y equals 0. This becomes x equals 3. I like to write those out. You don't have to. And then if you go back to your parent function, where would our, this is my new origin, right? So I'm basically going up 1 and over 1 from that. So to the right 1 and up 1 here, to the left 1 and down 1 here, and there are my points, and here's my graph. Okay, arrows on the end. Domain, what's your domain? All real numbers. What can't x be? I had a shift right, so x can't be positive 3. It's going to get really, really close to positive 3, but it's never touching. Range is going to be all real numbers. Y does not have any shifts up or down, so y cannot be 0. So it can't be 3, can't be 0. Moving on. All right, now, this is a good one. Here's why it's a good one. K value, negative. Got a shift where? Always right next to it. Left 2 units, down 1 unit. So, first thing I always do, what's the parent function? Parent function, negative 9 over x. Take the square root of 9. I'm thinking, okay, 3 is going to be that point, up 3, down 3, right 3, up 3, whatever, down, all the directions that you're going to go 3 units in. But I got to apply my shifts. Step number 2, asymptotes. Where are they going? Put those down there right away. Left 2. It's a positive 2. Think opposite. It's a plus 2. That means you're going to the left 2. So here we go. That's x equals negative 2. And down 1. So there's your asymptotes. This is your new origin. From that point, you're doing your 3 units. So from here, now, don't forget, this is where kids are going to go wrong. What's your k value? It's negative. So that means I'm going to be in quadrant 2 and quadrant 4. So I'm going to the left 3, 1, 2, 3, and up 3, 1, 2, 3. And from here I'm going to go to the right 3, 1, 1, 2, 3, and down 3, 1, 2, 3. There. Something like that, arrows on the end. Something like this, arrows on the end. Domain, all reals. What can't x be? X cannot be -2. Range, y values. Your y values are all real numbers except y cannot be. I had to shift down to -1. There you go. Okay? I think I'm going to actually skip this one because we've done ones like this before, and for the sake of time and to keep things rolling. The reason we gave you this one, the reason I wanted you to see this is so that you would remember that this is 3/4 over x. There are no shifts on this one, and so all you're doing is really taking the square root of 3/4. Asymptotes would stay right on the origin, and you're moving k values positive, so we should be here and here. You know what to do. All right, the last two can get a little crazy. So what do you notice about number 10? Well, you have some movements, but you have something in front of the x, okay? And if you notice here, 9, the coefficient of 3, and the 6 are all divisible by 3. And so what we want to try to do is get the coefficient in front of the x gone. We want to divide that out. And so if I divide everything by 3, because all 3 terms can be divided by 3, that's when I can do it. Now, if this was a 9 and that was a 3 and this was like a 4, I couldn't touch it. We'd have to go a different route. But for this example here, I'm going to divide everything by 3 and basically rewrite this as y equals 9 divided by 3 would be 3. 3 divided by 3 would just be x. And 6 divided by 3 would be 2. So that's really what I have here. Okay? That looks a little bit nicer. What's the parent function? So the parent function, put it in quotes, is really 3 over x. So when I take the square root of 3, okay, second square root of 3, I get 1.7. So roughly 1.7. But I have a shift. So my shift is to the right 2. Take my pen. To the right 2. I have no shifts up or down. So that's going to stay right at y equals 0. This is x equals positive 2. And there's my new origin right there. And from that point, I'm going to take my 1.7. My k value is positive, so I'm staying right here, 1 and 3. I'm going to go to the right 1.7 and up 1.7, dot, to the left 1.7, down 1.7, dot. I don't need any more points. Feel free to make a T-chart if you want. If you want more points, that's fine. For the sake of time, it'll be all good. Okay, there you go. Domain. X. Domain is x. X values, all real numbers. X can't be 2. I shifted it right to. Range, y values, all real numbers. Y cannot be 0. I didn't have no shifts. Try number 11 on your own and we will be done. Okay, so you'll notice here that I want to get rid of this 10. So I'm actually going to divide, whatever this number is in front of x is what you're going to divide everything by. And you're thinking, wait a minute, 15 can't be divided by 10 evenly. Yeah, you're right, not nice and neat, but you end up getting 1.5, and we can leave it as 1.5. So when I rewrite this, okay, I'm going to divide everything out by 10. So I'm going to get y equals basically 1 over, let's see, x minus 1.5, and then I have my plus 3, okay? And so what I'm going to do now is, what's my parent function? My parent function is basically y equals 1 over x, okay? So if I take the square root of 1, I get 1. My shifts is going to be to the right 1.5 units, so I'm going to have something that looks like this. I have a shift of 3 units up, 1, 2, 3. And there's my new origin, okay? And I'm taking the square root of 1, so that's to the, and my k value is positive, so I'm going to be 1 and 3, so to the right 1, half, and up 1, point, to the left 1, half, down 1, here, and make my graph here, and here. Domain, all reals, x can't be. I had a shift. This was my y equals, what was it, y equals 3, yeah? And this is x equals 1.5. That's why I like to write those out, because it helps me with my domain and range. So it can't be 1.5. My range is all real numbers. Y can't be 3. Done. Okay, inverse functions with shifts. If you have any questions, let me know. Look forward to talking to you in class. See you.